Hi, everyone, and welcome. My name is Adam Ernst. I work on the core team here at Facebook on iOS. Been here for about a year on iOS. So most of today, we've talked about using Facebook as a platform for your own apps, and the APIs, the tools, the things we expose that let you do that. So now I want to kind of shift gears and talk about internally, kind of pull back the curtain and let you see how we make the Facebook iPhone app, the techniques we've used, the process we went through. So I'll start with talking about some history, right? A lot of you know that recently we decided to rewrite the app in native code for version 5.0. So I'll talk about the way we came to that decision and how we actually executed that. I'm going to talk about the breakdown that we have at Facebook between the core team, which I'm on, and the product teams, which develop the products, the ones that you actually use day to day. I'll talk a little bit about the release process we use at Facebook, because that's something we've really invested a lot of time and effort into getting right, and maybe some of those lessons you can take and use for your own apps and your own development processes at all of your companies, because we've learned a lot along the way at a company as big as Facebook. And I think some of the lessons apply to all companies, really. And then for the engineers in the audience, those of you like me, I'll talk about the actual technical tools we use to develop our software and the process we go through, the kind of workflow that you would see day to day if you were a Facebook engineer, and how we also ship the build out to dog food it internally, how we get beta testers at Facebook to try out the app and find us crashes, bugs, all the things we want to really nail and get right before we ship it, and how we're also working to find defects in a different way, which is unit testing. Unit testing is really important to us at Facebook, and I'll talk about our philosophy and how we actually execute that. And finally, I'll give you a little sneak peek about the future of iOS at Facebook. So some history, a lot of you who have used the iPhone for a long time might remember that the first versions of the Facebook app were actually native. It was written by one engineer who kind of wrote it up. He was like super wizardly developed it in a weekend. No, not really. But it did everything you wanted to do at the time, and it was a really good app. But Facebook was growing really fast. We always had new products. Old products were going out the door. It couldn't be on one guy's shoulders to develop this app. And so a few years ago, we had to find a solution to kind of keep the app updated. And Facebook has always been a web company. We've got the web in our DNA. And we needed to find a way to make all these products fit into the iOS app. So we decided to use HTML5 and JavaScript within kind of a wrapper native app frame, which is something I'm sure a lot of you are very familiar with. You've heard it a lot, and probably a lot of you even use it for your own apps. And this was a few years back, so at the time we developed our own framework for doing advanced integration. For example, in HTML, you can't do photo uploads. So we developed a bridge to let you do that in the Facebook app. We even had a way to mix native apps and web components on the same screen of the app, so that we could do some really advanced stuff, which, by the way, is a really, really, really difficult thing to get right, so tread warily. And this is back, a lot of you are familiar with Sencha Touch, perhaps, which is a similar framework nowadays. There's a lot of other ones as well. So basically, this was back before that, so we had to develop our own. So this got us some really, really important things, the biggest of which was instant updates. If a product team at Facebook developed some new feature and wanted to roll it out the next day, they could just roll it out using the web app. It would automatically land on iOS, Android, and mobile website the next day. This is huge for a company like Facebook that wants to move fast. Second of all, it made A/B testing really, really simple. Because at Facebook, we have a saying that data talks, right? If there's a disagreement about how to do something, there are some companies that just kind of play it by the gut. But we try to get data on every decision we make. So you could roll out in the web, it's really easy to roll out two different versions of the same feature that do slightly different things and kind of conclude based on that which is the better one. And web makes that easy. And finally, one code base, right? This is the holy grail. Java was the original one code base. Now it's like the web. And so this let us do features without having to write it 3 times for native iOS, Android, and web. Unfortunately, it also brought us a lot of frequent performance problems. I'm sure a lot of you are familiar with the spinner you'd see for a long, long, long time. Because every time you'd be shipping down the entire news feed, not just the content, but the application to show news feed through JavaScript and CSS. And of course, one thing that really got to us was the lack of a multi-threading strategy in web apps. There's been some progress recently with web workers and other APIs that let you do that kind of multi-processing. And that's definitely coming along, and no one is cheering for it harder than Facebook as far as getting that done. But when we were doing this in iOS, there just wasn't a good way to offload work off the main thread and prevent it from blocking user interaction. So that was something that really was hard for us. Facebook is a really complex system of rendering. So if you think about every story as a div, there's a lot of different sub-elements and sub-ways that could render. So when you have so many stories in your news feed, you can think of it kind of getting out of hand. And we had a lot of problems with DOM manipulations and layout. We had problems with memory management. And this is something I think that is really, really, really difficult to do in HTML properly. For example, when an image, like we have those large, immersive photos in newsfeed, and you actually can do it in HTML. If a photo scrolls out of the viewport, you remove the attribute tag from the image, or the source attribute from the image tag, and then it won't use memory because it's off screen and it won't render that photo. But it's really, really hard to manage all that kind of hackery to make sure that you manage your memory. And last, and this one is that really gets to me as an engineer, is that debugging is really hard. There's no really good interactive debugger. You can kind of hack one together. There's some frameworks that let you do it now. But getting a proper debugger and stack traces is really hard with web. Limited animations also really held us back. We've got a lot of really great design talent at Facebook. And when you want to do kind of crazy 3D effects, now we have CSS3. That's really coming along. It's not quite there yet, but it's definitely getting there. But we want to do some amazing things. So anyway, we started this Facebook for iOS 5.0 as an experiment. We wanted to see, could we achieve better results from native code, and could we make it scale for Facebook? Because you remember the previous problem we ran into with native code was we didn't know how to scale it up to all the other products. So this was a really high barrier because we had to rewrite the entire app in native code, all the story renderings, and trust me, there are a lot of story renderings on Facebook. We had to rewrite all the like and comment interfaces, all the settings and bookmarks displays, and we also didn't want to disrupt the company for something that might not ship. Right? At the time, we couldn't just pull everyone off their product and say, hey, stop everyone, drop what you're working on, you have to rewrite in iOS, because they're like, what? Like, we have our own things to do. And at the time, there weren't really that many iOS engineers at Facebook anyway. And Facebook has these great programs now where we try to train up anyone who wants to learn iOS or Android programming. They'll send you through a course if you haven't done it before. But at this time, we didn't really have many iOS engineers, and we didn't have that training program yet. So we did something which is really big in Facebook culture, which is called a war room. When your project is really down to the wire and is important to the future of the company, we put you in a war room with all the other engineers that you need to work with. You're kind of locked in a small space. It gets a little uncomfortable sometimes, but it really makes communication easy, right? So we had some web engineers in there that would help us get the data we needed to render the app. We had the designers we needed so that we could really work with them cross-functionally in a really easy way. And we had all the engineers we needed right there, so we could just talk to each other and keep up to date. So it wasn't a straightforward, like, one-shot and it's done project. I'd love to say we did it in a week, but we didn't. It took us almost a year. And there were a lot of changes along the way as well. So we started really using the APIs that get data in and out of Facebook, not just sending down a web page like we used to. And so this really led to a rethink and a realization that we needed some more data from those APIs, and we kind of tweaked them accordingly. And I think a lot of you as API developers also benefit from this indirectly, right? Because we're eating our own dog food and using that API, so you probably get a lot better experience in the end. We developed a lot of advanced rendering techniques because we wanted to make feed completely smooth. In the old web world, we had a lot of problems with dropped frames and things getting kind of out of control. So we developed a lot. Our goal was never drop a frame. A goal I don't think we've quite accomplished, but we've tried to get really close, and we're always trying to get closer. And finally, when we set out on this project to rewrite the app in native code, we made a really crucial decision early on. And that was, don't make any design changes. We didn't want to get sidetracked with changing how the app worked or what it looked like or how it felt. So we just were going to re-implement what we already had in web code, make it native, and make it fast. That was it. But along the way, things change, right? So some of the designers just couldn't resist putting up some really amazing designs that we thought were really cool and fun to work with. A lot of you probably use the Facebook app, and you're familiar with the throw gesture for photos. If you're looking at a photo, you just kind of throw it off screen, and it flies back to where it came from in your newsfeed, right? That's like addictive. I love doing that. And when they demoed it to us, we just had to add it to the app. And that's something that would have been really hard to do if you think about it. How would you make a full screen view in a web app? It's definitely doable, but it was way easier in native code, so we had to add that. We had a lot of wrangling with core data and core animation along the way. Core data, we actually do use core data for our data persistence layer in the app. I like to use Winston Churchill's quote about democracy. It's the worst data persistence framework out there except all the other ones that have been tried. Now, I don't want to knock Core Data, because it actually is a really well thought out framework. It does a lot of things that are great, and it definitely saved us a lot of time compared to rolling our own. Core Animation, also wonderful. So we shipped the app internally to everyone in the company around mid-2012. At this point, it was a really rough cut beta. Definitely wasn't there, but we wanted everyone to try it and get it in everyone's hands and see what they thought. And the reaction was that we really liked it. We thought this was a huge improvement. We definitely noticed the performance boost. We decided we need to get this out in users' hands. So we shipped it. This was August 2012. We shipped version 5.0, the new native app. Had a huge reaction from the press. They thought it was a big improvement. But more important to us at Facebook than what the press thinks is what the users think. And when we polled users, we found that their perceived speed of the application was way faster. The ratings in iTunes and the star ratings there, which we actually do read through and try to evaluate all of those as best we can, were way up. Definitely people thought it was an improvement. And whether you measured it with a stopwatch or whether you measured it by what people thought, like perceptually when they used the app, we found the app was about twice as fast. So definitely an improvement there. So at this point, we had done what we had set out to do. We had relaunched the app in native code. We had achieved the performance goals. Now we needed to make it work forever, right? Because we'd been down this road before. We'd had a native app before. How are we going to make it work so that we can keep developing it and keep it up to date? Because we realized soon that a few iOS engineers in a room isn't going to cut it. What really is key here is making the processes so that everyone else at the company can put new features into the app in a stable way so that it doesn't destabilize the rest of the app. And we really wanted to make Facebook a mobile-first company. I'm sure you've heard that slogan. Mark likes to use it a lot. The idea is that Facebook should think about mobile first, and then we'll port features onto the web as needed instead of the other way around, which is how we used to do it. And so let me tell you a little story that kind of illustrates the problem with the few engineers in a room approach to doing development. The newsfeed team, around the time we were putting the finishing touches on version 5.0 and we're just about ready to ship it, finished this phenomenal new story type. The story type was called Pages You May Like. It basically uses all these advanced artificial intelligence algorithms to kind of guess which pages you might like and then show them to you in your newsfeed so that you can interact with them and like them and get updates from them. So if you come from a town and a lot of your friends come from the same town and all of your friends like a certain sports team, we can guess with a pretty high probability that you're going to like that sports page, right, if we showed it to you in newsfeed. Great way to get people more connected and get them more stuff that they're actually interested in as opposed to just noise. But the newsfeed team wasn't really thinking about the version 5.0 native rewrite because at this point, it was just engineers in a room. And we didn't know about all the newsfeed developments that were going on in other parts of the company. Because sure, we've got some friends in the newsfeed team. We hang out and talk a lot, but we don't necessarily talk about every single development that's underway. So at one point, the executive team realized that we didn't have Pages You May Like in the initial version of the native app that we were going to ship. And they realized that we really, really needed this feature. It was going to really degrade the experience if we didn't have it. So we had this mad dash to port this unit to HTML5. Or not to HTML5, to version 5.0, rather. We had a second war room on top of the first war room. We had some more web guys in there, and all the native engineers trying to figure out how to get this story rendered. And one of my friends was on this team, the second war room that had the mad dash to port Pages You May Like to version 5.0. And I remember him coming out of that room with red-rimmed eyes. He'd been in there for hours and hours and hours hacking and hacking and hacking, trying to get this to work, because we wanted to stay on schedule and get this app out the door. And as much as those heroics are great, and I really think that's a wonderful dedication to his job, as engineers, and of course as product managers and managers even more, we definitely do not want to repeat this experience all over the place. We don't want to constantly be in a mad dash to catch up where we want to be. So we realized that we had a problem, and that we needed to find a way to keep abreast of all these product developments and all the different teams and get those features in the app, and that it wasn't going to scale with just one team. On top of this, all of the teams had great ideas for the new features they wanted to add to their products with this new native app, because now they could use all the system APIs without using complicated bridges. So we couldn't really prioritize all of this as one iOS team. That was just not going to work to have a functional group of like the iOS team and the web team. So we also had multiple apps at the time. We had not just the Facebook app, but the Pages admin app, the camera app, the Messenger app, and we had recently acquired Instagram, which started using some of our shared code as well. So that needed support. So we realized that what we wanted to do is break up the team so that instead of being divided by what you do, iOS or web, it's divided by product or function. So I'm on the core team. And our job is to support and assist all the other teams by building the shared libraries that kind of underlie the app. And it's also our job to investigate cross-cutting issues. So for example, if there's an issue that affects multiple products, or that you can't really track down where that issue is coming from, like a mysterious crash or some kind of weird bug, that's our job. We fix it for you. Our job is also to keep the app really fast and clean, because I'm sure you've heard of the tragedy of the commons, right? If there's not an owner for one component of the app, it just kind of degenerates over time. People slip some hacks in, and it gets really gross. No one really feels like they're an owner of that part. So we try to keep the architecture of the app really clean and well thought out. You can think of this as kind of a sandwich. On the bottom, we've got the core team that does kind of the shared libraries and all that stuff. On top of that, each product team builds the products that they want to use. So we've got photos, feeds, search, and some great ones. We've got the search team now working with native, which should be great. And then on top of that, there's actually another part of the sandwich that I haven't talked about yet, and that's the release team. Now, the release team is made up of a few release engineers. So their job is to take a very uncut, unstable build of the app that we have internally and get it ready and ship it out the door to our end users in a really stable state. Because we have so many tens of millions of users, we don't want to ship something that's really bad. It's going to cause a lot of problems. And the release team also has an on-call component. So I was just an on-call about a couple weeks ago. And we take a rotation of volunteer engineers from all the different product teams and the core team. So it's not just core, but also product. And they volunteer to help track down issues, report bugs, triage cases, and figure out all the issues. So let's talk a little more about the release cycle, because I think that this is something that you can definitely take use of in your own apps and whatever mobile apps you're developing. So at first, we started with a simple model. In the next release, we're going to do features A, B, and C. So we round up those product teams. We say, you're going to do it in the next release. Go. Start programming. But the problem is that we're kind of at the mercy of whoever does this slowest, right? So if one of the teams is really lagging behind, we have no choice to wait for them, because their half-finished work is already checked into the code base. We can't ship something that's half done, and this really slowed us down. And at Facebook, we really want to move fast. So we decided to take a cue from another software company, another software organization, and that is Mozilla, which is not a surprise because we have a lot of ex-Mozilla people at Facebook. And the thing we borrowed from them was the idea of a fixed release process. And how this works is you choose a cadence, if you will, and you ship an update every X weeks, whatever your value of X is, and come hell or high water, that build is going to be out the door, right? You need to make that date. Otherwise, the process just doesn't work. So Mozilla uses this for Firefox to kind of get their Firefox development on track. But how are we going to use it at Facebook? So we chose an interval, currently targeting about every 4 weeks. We've experimented with longer cycles, and we're trying to even go shorter, maybe, possibly, thinking about it. And within those 4 weeks, we have kind of 2 sections. The first is stabilization. So we have a really crashy build where our crash rate is like through the roof. You would not believe it. This is only for internal users, of course. And we aggressively track down those crashes, try to fix them, get stuff done. And then we also have a period called the soak, something I definitely think is worth doing. And this is where we just try to leave it. We don't try to put in a whole bunch of fixes. Even if there are bugs, as long as they're not terrible and world on fire bugs, we'll just have to ship it, because that's what it means to write software in this way. And this kind of lets us find issues that were not immediately obvious from using the app, but which come out in the week or so of using software. This is definitely, the soak period is something you can definitely benefit from. I used to be an independent software developer. I didn't do a soak period, right? I just did the write it in Xcode and ship it to Apple thing. And I've definitely had bugs discovered that I would have discovered if I would have done a soak period on my own apps. So this also means that we need to change how we write software. And the way we do this is that we build features with an off switch. You have to have a way to turn your feature off if you're developing a new feature in the Facebook app. Every product team, every feature they do. Because this is why. When we get in that stabilization process, you get a chance to fix any crashes or bugs you introduce. But if there are too many crashes, bugs, issues with your feature, we can't ship that. We can't go down to the wire and try to fix things at the last minute and introduce a lot of crazy unsafe fixes. So the idea is that at a certain point, if your feature is still not done and it still hasn't been stabilized, we just turn it off. Flip the switch, so to speak, that nice big toggle. And we turn off that feature and try it again the next time. And you know that since the releases are every 4 weeks, product teams don't mind that they have to turn off their feature and try again next time, because they still know that their feature is going to get out in 4 weeks from now at the next cycle. They don't have to worry that maybe the app won't ship another update for 6 months, and that they won't have a way to get in. So we try to use runtime switches for this because it makes testing a lot easier. You can just kind of switch the feature on and off at will. But for some changes, we've also needed to use runtime like define or compile time defines, where you actually have a switch there to change the behavior. So let me give you an example of how we actually use this. This is a great story. So we introduced a new like bar in the app in early 2013. Here's a nice story. This is actually from when we acquired Instagram, and they came to hang out with the Facebook Photos team. One of our engineers at Facebook posted this to his timeline. He uses TimeHop, which is a service that kind of like reminds you of things that you did 1 year ago. So that's a great memory, right? Like having Instagram come to our campus for the first time, awesome memory. And at the left, you see the old like bar, and on the right, you see the new like bar. It's got these great big tappable buttons like, comment, share, that just kind of cry out to be tapped. And it's also got that likes comment there. It's got a really cool animation when you tap the like button. I'm sure you've probably all seen this if you're using the latest version, because by now it has shipped. And the thumb just kind of jumps out at you. It's really cool. So we had been testing this on the mobile website, and we knew that it was a big improvement. People really liked that new bar. So we had an iOS engineer write it up in native code and get it ready to ship. We shipped it to our internal testers and saw what they thought. Everybody liked it, except there was one bug. And that is that if you had no likes and no comments on the story, it would actually look like this. If you keep your eye on the 3 likes, 1 comment, it'd have this big white bar. We had forgotten to readjust how high the story was when there were no likes and no comments. And so we thought, well, maybe it's not so bad. Let's try it out and see what people think. Had some people complaining, but we weren't really sure. And then about 3 or 4 days before we were ready to ship this new version of the like bar, Mark came and said, you know what? We can't ship it like this. This looks wrong. It feels wrong. Let's do it the next time and do it right and get the actual sizing right. And so you can imagine if we hadn't built it with an off switch, we would have had to crawl through the code base and try to resurrect all the old code out of the repository and stick it in and re-enable it. And then, of course, we would have refactored something, so it would have broken, and we would have had to figure out and reverse engineer how to get it in there. All in 2 days because we had to ship. But because we had built this with an off switch, we still had the old code in the repository right there, waiting. We don't keep old code around indefinitely. Once the new feature ships, we take the old code out. But until it ships, and at this point it hadn't shipped yet, we still have the old code there. So it was all set and ready. All we had to do is flip the switch, ready to go, old like bar, and we shipped on time with not a sweat. Didn't have to worry about it. Definitely highly encourage that if you're developing major new features in your apps. Very handy. So let's talk about the actual tools. Engineers in the audience, this will get you excited. So our goal at Facebook, our cardinal company goal, is kind of move fast. We don't want to slow you down. We don't want to drag and make things take a long time. We want you to be able to concurrently develop new features on master so that teams aren't slowed down. While meanwhile, over here, we're kind of stabilizing the release and getting it ready to ship it out. So this also means that our another goal is don't break master. Right? That's really important, because if you break master, you're slowing down every other engineer at the company and blocking them, and they can't get their work done. So at Facebook, we really love posters. You would not believe how many posters we have hung up in the Menlo Park headquarters or here in New York, where I work. So we made some posters, don't break master, hung them up as kind of a reminder, if you break master, you're slowing us all down. Love those posters. So the process an engineer actually does day to day is make changes on your local branch, on your machine. You put them up for review on a code review site that we have internally, which I'll talk a little bit more about in a second. And here's something that I really love about working at Facebook, and that is that all of your changes are automatically checked for build failures and unit test failures. You remember that slide back where I showed all the icons of all the apps we have under development? It's really easy to make a change in one app that seems really harmless and not at all invasive, and then find out that it breaks another app in a terrible way. For the longest time, we didn't have the tooling to do this, but now we do. So every time you submit a change up to that server before you ship to master, it automatically builds all the projects and runs all the unit tests, which is a process that would take 40 minutes if you didn't have it automated. But we do it in parallel, so it actually takes no more than 3 to 5 minutes, and you know instantly whether your change is going to fix everything or break everything. Meanwhile, while it's doing all those builds, you can also, the other developers on your team can come along and start giving code review tips. So they can say, this is awesome, this is great, or they can say, well, let's tweak it in this way, and it would be much better. And then once your changes are approved and they've passed that asynchronous build and test phase, then you can push to master. So for source control, we use Git, which I bet almost everyone in this room uses by now. Designed for speed, it's fantastic. Open source, so we can tweak it when we need new stuff. And the best feature of Git, in my mind, is local branching. So you can have like multiple feature branches locally, which is definitely handy because you can do 5 features in parallel versus the bad old days of SVN, which I actually remember when like you were screwed, right? You had to like copy a branch, and that was just a mess. There's Fabricator for code review. Now this is a tool that was actually developed at Facebook, but it's open source, developed by Evan Priestley, one of our earlier engineers. And I definitely recommend using it if you don't have a great code review tool that you love, or even if you do, give it a try because it really has some great features. It's basically just a discussion forum for every change, and you can do inline comments and code diffs just like most code review systems, but in a very nice way. It's very fast, very performant. I love it. So here's a sample image of Fabricator and a diff that we have. You can see the author and reviewers there, and then you can see the async build section. Let's zoom in there. So you can see here that he made this change, but it actually breaks the Facebook build, so that you wouldn't want to push this to master, because even though all the other projects, maybe he was working on Messenger or something, so he didn't notice, but all the other projects build just fine. But if you actually try to build Facebook, it'll fail. And if you clicked on the try FB iOS link there, it would actually open up a build log showing what failed, so you don't have to like do it on your local machine. And if we scroll down here, we can see the summary, which is your area to talk about what your change is doing, but also the test plan. We require every engineer at Facebook to write out a test plan saying what their diff is doing and how they tested it, so that we can verify those tests and make sure that you've thought appropriately about how to test your diff, because it's really easy to break other things. And then we've got some inline comments here, along with one of my favorite features of Fabricator, which is image macros. So when words just aren't enough, we've got some great funny pictures. We've got all kinds of inside jokes. Here are some of my favorite non-inside joke image macros, especially the one in the bottom left. That's like my favorite. So another tool we use is called ArcLint. I believe this is also open source. It's actually part of Fabricator's command line client called Arcanist. Could be wrong on that, so if you can't find it, drop me an email and I'll help you find it if it's open source. And this tool lets you set up rules to catch common mistakes in your code base. And when you're at a company as big as Facebook with so many developers, this becomes really important. So if your company is growing and adding more developers, definitely start thinking about linting. Because it was never something I used when I was an indie developer, but at Facebook, lifesaver. So we warn you against using certain symbols. We catch common mistakes. Here's some sample code, right? So a lot of you might be familiar with the voiceover feature in iOS, which it lets people that have disabilities or other problems use the phone in a really, they can still use your app even if they have visual impairment. So here we're setting an accessibility trait on a view, which basically tells VoiceOver how to announce that view to someone who's visually impaired. And then we also have a nice, straightforward dialog implementation there that's just releasing in iVar. Seems pretty easy. So when we run this code through ArcLint, it's first going to highlight the fact that we're using UI accessibility trait header, which is actually an iOS 6 only symbol. So at Facebook, we have so many users that we need to support back to iOS 5, and until recently back to iOS 4, which is a real pain, I'll tell you. And so if we use the symbol on iOS 5, it's going to crash the app. And what's worse, most of us aren't going to notice, because at Facebook, we like to live on the cutting edge just like you, and we use iOS 6 on our own devices. So we're at the mercy of some random Facebook tester internally using the app on iOS 5 and noticing, hey guys, this crashes, probably not a good thing. But lint comes to the rescue here and highlights all of these symbols and says, hey, you shouldn't use this because it's not available for iOS 6. Why this isn't in the compiler, I have no idea, but it's not, and lint is really helpful here. Second of all, there was actually a typo in that code, and we were calling my iVar dialog instead of my iVar release. Now, this may seem really stupid and simple, like who would ever make that screw up? But I tell you, I've already twice made that screw up, and lint has caught me both times and told me, no, you did not want to call dialog on an object because you never, ever, ever do that. You wanted to call release. And the best thing here is that it even gives you an auto patch, right? All you have to do is type Y and hit enter, and it automatically does the correction, amends it to your current commit and Git, ships it up to Fabricator, to the code review site, and you're good to go. So definitely a handy feature. As far as our continuous integration system, BuildBot, this just kind of it's literally a rack of Mac Minis, because we have so many developers now that we need a full rack of Mac Minis in one of our data centers. And it just sits there and builds all the projects all the time. We have like a system that tells it, pings it when it needs to do that. And if you do manage to sneak around the BuildBot and push a commit that breaks master in some way, blocking every other iOS engineer in the company, it even emails you and says, hey, not only did you not pay attention to that red block in the fabricator, you just broke the build. Nice little build status failure there. So this is an email I've gotten a couple times working at Facebook, and it really makes your blood run cold, right? Because now everyone's mad at you. They can't work until you fix it, so you better get on it. Also, if you actually do that, we'll just revert your commit. Like, we can't block the company on everything. So we've got a great process for just like identifying commits that are bad and reverting them right away. So we don't like, we're not at the mercy of developers actually fixing their own mistakes. As far as builds that we distribute internally, we've got a nice process where we sign the build using an enterprise distribution profile, which is really handy because it means you don't have to collect everyone's device IDs for beta testing and then keep them all up to date. You can imagine that would be a nightmare at a company of our scale. So enterprise distribution profiles let you sign your app, distribute it to everyone, and they can all use it without having to do that kind of registration process. Definitely highly recommend that for your beta test processes if you're not already using it. Most people have already picked up on that trick. One trick which is a little more obscure, so you should definitely think about this, is use a different bundle identifier for all of your different builds. And this means the App Store build should have one bundle identifier, but then if you do a beta test build or development builds or any other kind of branch builds, use different bundle identifiers and different provisioning profiles so you can actually have them installed side by side on your device. Because this is like really helps me out because I can go ahead and like compare two versions of the app really easily. And we also burn the build number into the icon. A designer came up with that during a hackathon or something. You can see there that little blob in the bottom left of the icon. You can't really see it, but you can on the device, is the build number that it was built from. We've also got a nice little golden icon there. That's for the golden master that we're going to ship. Nice little like golden master play. I like that. So for most iOS engineers at any given time, they're worried about two branches. One is master, and the other is release. So the idea is that master is where all your stuff can go. You can check in anything there as long as it doesn't like totally break the build. And then in the release, that's where we try to stabilize it. And to use that, we use Relief, which is a part of Fabricator. So it's also open source, and you can also use it. It's a great tool. It's pretty recent. It was only developed in the past, I don't know how many months. And the idea here is that as engineers, we always believe that our fixes are perfect, and that it definitely just fixes the bug and doesn't break anything else in the product. But release engineers know better than that, right? They know that oftentimes what seems like a really simple, straightforward fix is going to break the app in some other way that's really obscure and even harder to notice. And so it's kind of dangerous to take fixes when you're down to the wire. So the process behind Relief is that engineers nominate their changes. They say, I want this change to go into the release branch after they check it into master. And then the release team gets to look at an interface like this and decide if it should or not. So in the upper left, we've got the size of the commit. You can think that a small commit with very few lines of code is probably safer than a 2,000-line megadiff that they want landed in their release branch right away, because it definitely fixes the bug. They've also got churn, so they can see, if you think about the review process, if someone just puts up a diff and it's accepted and pushed, that's probably safer than a diff that was put up, rejected, revised, rejected, revised, rejected, commented, revised, and then finally pushed. So the churn kind of gives them an idea for how controversial a change was. Over here, we've got the person who requested the release and their karma. So we've got a nice little karma system. Everyone starts out with 5 stars. And then depending on how you act through the release process, you can kind of get knocked down or up a star. And the best part about this is that it's secret, right? Like, I don't know my own karma rating. Only the release engineers know that. Down on the left hand, you've got the approve and reject buttons. And this is amazing because it does it all for you automatically. If you think about how you'd have to do this more workflow manually, and maybe some of you already do this workflow manually, you'd have to like, check out the release branch, do a git cherry pick for the rev you want to pull in, run all the tests and everything, and then push it out. But this does it all automatically. If you click approve, it does the cherry pick on a server somewhere, runs all the tests for you, and then pushes it to the release branch, all automatically with one button click. Amazing time saver. So testing is also really important to us at Facebook because as much as that stabilization process really works well for us, it'd be better if we didn't even have to find these bugs in the first place because they didn't exist. So we're trying to ramp up our automated testing usage so that we can find bugs before they happen. So what's not in Facebook's culture is having like test engineers where the hotshot engineer writes some new class and says, all right, you write all the tests for it, go to it. And it's also not in our culture to have a QA department, a really large QA department where you write a crashy, buggy app and you throw it over the wall and you say, all right, file some bugs, I'll fix them when you file them. But what definitely is in our culture is having a high-quality, reliable user experience. This is something we realize is really important when we have so many users and you use Facebook so much every day. You don't want to have crashes, problems, bugs. So we believe in having developer-authored unit tests. If you write new code, you write the unit test to go along with it. Really important to us. So taken to the extreme, this is test-driven development, popularized by Kent Beck, where you write the tests first, and then they should fail because the code isn't written yet. And then you fill in the code, make your test pass, and then you can refactor with kind of the assurance that your code is still correct since the test pass. Not every Facebook engineer actually uses this process, but I do know some that are very insistent about it, and they say it really helps them. But iOS also has some shortcomings here. It's not really a match made in heaven. A lot of iOS engineers, including myself, were not really familiar with unit testing in iOS before they came to Facebook. And Xcode support for testing is not ideal. If any of you are Rubyists, you might have it set up to run your unit tests every single time you hit Command-S and save your file, which is really amazing because you get really fast feedback about whether you're breaking something. In Xcode, it's like a multi-minute process to build all the tests and run them and everything, which is kind of unfortunate. And we're also missing some key frameworks, like dependency injection frameworks and UI automation testing. There are definitely frameworks that exist for that, but they're not necessarily the most mature, and they don't have all the things that we would really love, whereas Java has some great dependency injection frameworks, and there are all kinds of great UI testing frameworks on a lot of platforms, too. Xcode does have built-in support for Send Testing Kit, though, which is a test case runner. OCMock, highly recommend it, because unlike Java, you don't have to protocolize everything to test it. You don't have to write all these interfaces and pass around interfaces instead of actual classes. In Objective-C, you can write real code that just takes real classes and then pass in a mock object that is not actually that class, and Objective-C will let you do that. Feature I really love that we love to use is called Rage Shake. This is only for internal users, so don't try this at home with your production Facebook app. It's not going to work. But the idea is that when you see a bug, shake the device. And not only does this let you take out your rage at seeing this bug that you really hate to see, but it also is great because it leaves the user interface in place when you report the bug. So you don't have to go into some menu and click report bug. It's right there. So we capture a screenshot immediately showing what you rage shaked so that the engineer really gets a good visual idea for what's wrong. And we also slurp up the network logs so we can see what the server is sending you in case it's a server bug. We send along the last crash logs. You can rage shake crashes. And we also send along the last 10 seconds of NS logging. So you can see the logs even though they're on someone else's device. And here's a great trick for your own debugging, whether you build this into a report bug feature or not. If you call UI application, shared application, key window, recursive description, it's kind of like this undocumented secret hack, it dumps the view hierarchy into a textual representation of all the views that are on screen. So we do that and send that text along with the crash report so that the developer can see what was actually on screen in terms of not just visually, but in terms of the actual view classes. We also have internal settings, which lets you tweak this on and off. This is only for, of course, internal use. So again, it's not in your app. You won't see it there. But you can kind of turn some features on and off. You remember I mentioned building features with an on-off switch? So you can actually turn them on. So this means that features that aren't finished yet are off. But if you really want to live on the bleeding edge, go ahead and turn them on in internal settings. Internally, we're allowed to do that, and we can see what it's shaping up to be. So this is where we've been. We relaunched the app. But if you remember what I said, our original idea was just rewrite the app in web code and make it faster. We didn't want to do any design changes. So we set up all the processes that let these product teams do their development inside the app. And it's been really successful because they are moving faster than ever before. And so you can just think about all the things that we have under development. You can barely imagine some of the features, some of the amazing visual effects, some of the new designs that are underway at Facebook. And we're very proud that we've enabled the product teams to do that in their own work. So for me, Facebook's a really exciting place to be. Right? We're doing all kinds of amazing product work. We've got a lot of things coming down the pipe. And I've had a blast shipping iOS 5.0, the new native app, and continuing to build it to this day. So now we have a minute or so for questions. If anyone has a question about how we develop 5.0 or any of the technical implementations, I'm happy to take any questions. Just wait for the mic to come to you.
Hi. How do you deal with the fact that Xcode projects and zibs and stuff aren't easily mergeable in version control?
The zib zone, we don't use zibs, is the answer. Okay. Not only because they're not mergeable, but also because they're really a pain to deal with localization. So all your user interfaces are written in code. And yeah, Xcode projects are not easily mergeable. We just deal with the pain. We have merge conflicts once in a while, sadly.
Mike Putnam from Rule of Law. Can you talk a bit about supporting multiple platforms and the decision to launch everything at the same time on all platforms versus not, how that goes?
Sure. So we do have to, like, we now do have to write every feature 3 times unless it's a web-based feature, which we do. We still do some web-based features. And we have a system that lets us roll out features in a controlled manner across platforms. Sometimes we'll hold a feature and you know, ship it in a consistent manner. Sometimes we make the decision to roll it out, you know, on different platforms at different times. Just depends on a case by case. Okay.
Hey, I had a question. Sajid from Foursquare. You mentioned that A/B testing was really important to your culture, and you were able to do it easily when you had the web views. I was wondering how you approach A/B testing now that you have a native app.
Great question. So 2 things. We still have the mobile site, and a lot of users still do use the mobile site, so we can A/B test the heck out of that, right? And so like I mentioned, the like bar, the new like bar, we had A/B tested that on the mobile site before we decided to ship it in native. And second of all, we didn't have it at the time, but we have been developing an A/B testing framework that we use to kind of do for native testing what we want to do for A/B. Cool. All right, that's all the questions I have time for, but you can come and grab me after the talk anytime. I'm happy to answer them. Thanks so much, everyone. It's been a pleasure. Thanks.
That was awesome. Thank you so much, Adam. All right, you have about 10 minutes. And then up here, we're going to learn a little bit about how we think about developing on Android. So Michael Bolin from the core Android team is going to be up here. If you want to learn more about the new technology partner program that Facebook announced today right here, you can go upstairs and listen to Christina Abernathy again. And she's going to have Parse, Adobe, and Microsoft up there with her. So you've got about 8 to 9 minutes, and then come right back here or go upstairs. Thanks.